Being able to identify similar triangles and understand how they work is something that will definitely be tested on the geometry questions on the ACT math test. You can identify two similar triangles in two ways. If two angles of one triangle are congruent to two angles of the other triangle, then you have similar triangles. In the example below that statement, you can see the smaller triangle has angle measures of 33 degrees and 42 degrees. In the bigger triangle, you can see that it has angle measures of 33 degrees and 105 degrees. If you have two angles of a triangle, you can always figure out the third angle of the triangle because all of the angles add up to 180 degrees. When you solve for the missing angle in either of the triangles, you'll find that they actually share all angles in common. So those two triangles are similar. The other way to figure out if two triangles are similar is if the lengths of the triangle's corresponding sides are proportional. So in the triangles below that statement, I have one triangle with sides of length x, y, and z, and then in the larger triangle, I have lengths of 2x, 2y, and 2z. Because the corresponding sides have proportional lengths, these triangles are similar. Sometimes the ACT will give you problems where similar triangles are kind of hidden. So let's do three common examples of identifying similar triangles. In the bottom left, you have triangle ABC is similar to triangle ADE, which is similar to triangle AFG. The reason why this works is because we have a transversal which intersects parallel lines, lines BC, DE, and FG. So we have line AF acting as the transversal to those lines. Angle A is shared among all three of the triangles, so of course it's going to be equal to itself. Angle ABC, angle ADE, and angle AFG are all equal as well, because they are actually corresponding angles. In the middle example, we have triangle ABC is similar to triangle DBA. This one's a little trickier to identify, but if you start recognizing these, then it'll make your life a lot easier when you come across a question that looks like this. So I'll prove that these are similar. Angle BAC is a right angle. Likewise, angle ADB is a right angle because it is a supplementary angle to angle ADC. Angle B is actually shared between both triangles ABC and triangle DBA, so it's equal to itself. Because both triangles now share two angles of equal measure, both of those triangles are similar. In the example on the bottom right, I have triangle ABC is similar to triangle ADE. We know that angle CAB is going to be equal to angle DAE because they are vertical angles. Likewise, because line DB is a transversal to two parallel lines, line CB and line DE, then we can determine that angle CBA is actually equal to angle ADE because they are alternate interior angles. So again, since we have two angles that are congruent to each other, these triangles are also similar.